In this video, I'm just going to go through a couple of guided practice problems so that you feel more comfortable in doing some of the work that I'm going to have you do before Monday. And so let's focus on this first example. This tab is in your OneNote under guided practice. So you can follow along there, or I definitely recommend having this in your notebook as well. Let's start here. First, we need to recognize what the parent function is, right? Because that's what's our whole basis and our whole foundation for making these transformations is going to be based on what our parent function is. In this case, our parent function is y equals 1 over x. And I'm curious, before we get started, can you tell me what transformations are occurring on this function? Hopefully you're able to say, yeah, mister, you know what? Since there's being this negative 2 is being subtracted from my x, I know that that means we're being horizontally shifted to the right by 2 units. Same thing here with this plus 4 being added to my function as a whole. I know that my function is being vertically shifted up 4 units. And so normally, right, we understand that our general parent function for y equals 1 over x, we have a vertical asymptote, horizontal asymptote on the axes, point at 1, 1, negative 1, negative 1. And our graph looks something like this. Very ugly sketch, but you get the idea. We just need to shift this whole graph to the right 2 units and up 4 units. And so I'm going to focus on my asymptotes first. So when I'm working with rational functions, I say your first step is going to be to figure out where your asymptotes are. All right, if our graph's been shifted to the right 2 units, that means my vertical asymptote is going to be at a value of x equals positive 2. If my function has been shifted up vertically 4 units, that means my horizontal asymptote is going to be at y equals 4. From there, nothing else has changed. So I'm still essentially thinking about, like, if this is my origin, the intersection point between my asymptotes, just like it was here, I'm going to go 1 unit to the right and 1 unit up. Boom, that's where I'm going to have a key point. I'm also going to go 1 unit to the left and 1 unit down, another key point. Mr. Filson, how do we know they're there? Because nothing else has changed. And if you want to double check yourself, let me finish graphing this first. It goes down. You should be following along your notes as well. If you want to check, I'll just go ahead and plug these points in, right? This point is 1, 1, 2, 3. When I plug in a positive 1, I get 1 minus 2, that's a negative 1 in my denominator. 1 divided by negative 1 is negative 1. 4 minus 1 is positive 3. Oh, look at that. Positive 3 for my y value. Love that. How about this point? 1, 2, 3, so I have 3. 1, 2, 3, 4, 5. Gnarly. Plug in 3 for x. 3 minus 2 is 1. 1 divided by 1 is 1. 1 plus 4 is 5. Excellent. We are good to go. Again, with rational functions, normally we want 3 key points minimum. This is a key point, this is a key point, and then your asymptotes essentially act as key points, quote unquote, as well. Nice. Let's talk about this square root function. Again, I'm going to have you tell me what types of transformations have occurred on this the square root function. Yep, so we actually have 3 transformations occurring here. We have our graph being shifted to the left by 1 unit. We have it being shifted down 3 units, and we have it being we have our amplitude as a positive 2. My first step always for most of these functions is going to be to start with what I determine my main key point and work on my horizontal and vertical shifts. And so normally, again, this graph looks something like this. I'm going to start with this point that's 0, 0. It's been shifted to the left 1 unit, so boom, we're here. and it's been shifted down 3 units. Excellent. So I know that that point on my original graph is going, which is at 0, 0, is going to be at -1, -3 on my transformed graph. From here, if that was all that was happening, if this 2 wasn't here, then we just graph our parent function like normal. Again, I said it was really important that we understand key points because it's going to make it super easy for us to graph. So if we're starting from our origin, remember the next key point was over 1, up 1. Then it was over 4, up 2. Then it was over 8, which 1, 2, 3, 4, 5, 6, 7, 8, up, or no, 9, excuse me, up 3. Boom. That's what it would look like if we didn't have that amplitude issue going on. But we do. And remember, our trick based on our notes video was, okay, however much we usually go up, we're going to multiply that by our amplitude. And so in this case, we're starting here. Normally we'd go over 1, up 1. Now we're going to go over 1, up 1 times our amplitude, times 2. So we're going over 1, up 2. Next key point. Normally we're going over 4, up 2. Now we're going to go over 4, up 2 times our amplitude, times 2. So over 4, up 1, 2, 3, 4. 2 times 2. And we'll do this last point here as well, just so you can see one more example of how we graph our amplitude. Normally, we go over 9, we go up 3. Now we're going over 9, and we're going up 3 times our amplitude. 3 times 2. So now we're going up 6. Over 9, 1, 2, 3, 4, 5, 6. The green graph is this function here. You do not need to include this dashed function that I've shown. That was for me to explain like how we're building off that and getting our amplitude graphed. Once you get more practice, you won't have to do that. But if you want to do that, you're absolutely totally fine to as a foundation for you. But make sure it is dashed, and I would say maybe like when it comes to tests, just go ahead and erase it. So excellent. Let's move on to 2 more. I'm going to go a little bit quicker, okay? So this function here, call this number 3. We've been shifted down 2 units, and we've been vertically stretched by a scale of 3, and we've been reflected over the x-axis. That's where that negative comes in. So again, my origin point, I know that's one of my key points on my cubes, my cubic function. So I'm going to shift that down 2 units. That's where my new origin is going to be. Next, normally, I'll keep this consistent. We'll go black. I'd have a point at 1, 1. Over to the left, down 1. Go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Same thing down. Looks something like this. But we have to account for our amplitude. We've been vertically stretched by 3. So instead of going over 1, up 1, now we're going to go over 1, up 1 times 3. However, we also have to again account for this negative sign out front. And so instead of going over 1 to the right and up, now we're going to go over 1 to the right and down 3 units. Over 1 to the left, instead of going down 1, now we're going to go up 1, but 1 times 3 because of our amplitude. Same thing over 2. Instead of going up 8, now it's 8 times 3. That's going to be way up here, so I'm not going to worry about graphing that. But this is what your transformed function will look like, the solid green line. All right, last one. Let's work with a parabola. I'm going to have you tell me one more time. What are the transformations that have taken place for this parabola? Excellent. Rightward shift 1 unit. Vertical shift down 3 units. Our amplitude, we've been vertically compressed by a factor of 1/2. I'm going to start with my main key point, which is here at 0, 0. Again, we've been shifted to the right 1, down 3. I'm going to graph that point first. Instead of going up over 1, up 1, now I'm only going up by 1/2 for the same reasoning I've given for the other functions with an amplitude that wasn't 1. Now instead of going over 2, up 4, now we're going over 2, up 2. Same thing in this direction. Over to the left 1, up by 1/2 for our amplitude. Over to the left 2, only up 2 because of our amplitude. There you have it. There's a graphed function for you. What I want you to focus on for homework is this leveled practice tab. I want you to do your best to attempt at least 3 problems, at least 1 from each level. So you do 2 problems from level 1 and 1 from level 2, or the other way around, 2 problems from level 2 and 1 problem from level 1. Highly encourage you to do all 6 to get more practice. It'll be very, very helpful for you. I will go ahead and leave the key on the OneNote for you as well. But I do challenge you, again, don't look at the key until after you've attempted these problems so you can check your work, see how you are doing, and make corrections as needed. All right? Folks, I know I've given you a lot of content. I just want this to be here for you, to support you, make sure we're on a good spot for Monday. Reach out with any questions, and have a wonderful rest of your weekend. We will see you on Monday. Adios.